Hi everyone, this is Preetika Chhotray. Me and my team members are students of Master of Applied Computing at the University of Windsor. This presentation has been made for our course Advanced Computing Concepts. We have created a web search engine called Atom. Our professor and project guide is Dr. Abed Alkhateeb. Atom is developed using Java on the Eclipse IDE. We are a team of three members. Me, along with Sneha Arora and Mayank Sehgal, have implemented the functionality of this project. Here are the individual contributions made towards the project. We have implemented four functionalities in Atom. I will be explaining about the working of the web search engine, web crawling, and HTML to text functionality. After me, Sneha will be explaining pattern searching, and page ranking. And finally, Mayank Sehgal will be giving you a walkthrough of the libraries used and the code that we have implemented. The tools used for this project are Eclipse IDE, JSoup, YouTube, and GitHub. Starting with the definition of what a web search engine actually is. It is a system which is responsible for searching information on the internet. There are three processes used by a web search engine, namely crawling, indexing, and searching. So when the user types any words or letters and clicks on search, the search engine crawls the web to index web pages and provides information based on user's search query. Web search engines can also be termed as data miners because data mining techniques like crawling, indexing, and searching are being used. Now, Sneha will explain the search engines used in today's world and features of our project.
Thanks, Pratika. So, as we all know, that Google is undoubtedly dominating the market in all the countries, but at the same time, there are alternate search engines in the market, like Microsoft Bing, which is ranked 30 in the most visited websites in the internet, followed by Yahoo, which is a famous web portal, very popular, and is ranked 11th in the most visited websites on the internet. YouTube is the second most popular search engine today, and it is estimated that YouTube processes more than 3 billion searches a month. Also, DuckDuckGo and Ask.com are the another few examples for the web search engines that are mostly used today. Coming on to the features that we have implemented in our project. So we have implemented four features, which is the web crawler, which is also known as a spider. So it's an internet bot operated by the search engines, specifically Google and Bing. HTML to text, where the parsing of HTML text to textual data is done via JSON. Pattern searching, where the string matching algorithms have been applied for the searching of the words, followed by page ranking, where the web pages are ranked in the search engine results. Following, Pritika will walk you through the first two features of of our project Atom, that is the web crawler and the HTML to text.
Thanks, Neha. A web crawler is also known as a spider or a spider bot, and it is used by web search engines. A web crawler bot is like someone who goes through all the books in a disorganized library and puts together a card catalog so that anyone who visits the library can quickly and easily find the information they need. Let's talk about how it works now. The main purpose of a web crawler is to download and index the information from the internet. The spiderbot learns about information which is present on every page so that information retrieval can take place as and when needed. The code for the web crawler can be found in crawler.java file. In our project, we are implementing the functionality of web crawler using hash sets. Here, as you can see in the screenshots pasted, our program asks us to enter the URL to be crawled and searches for the pattern as shown. In the second screenshot, as we can see, the web crawler is crawling the Geeks for Geeks website and showing in the output whether the URL has already been visited or is yet to be crawled. In the third screenshot, as we can see that once the crawling stops, the output is displayed as crawling has stopped. For the next functionality that has been used in our project, It's called HTML to text. For this purpose, we are using the JSoup library. JSoup is a Java HTML parser, which is used to parse an HTML document. In our project, we are using a web page, for example, Geeks for Geeks web page, and we are downloading the HTML files from there using web crawling. Apart from this, we are also using file handling concepts to write the crawl data in a folder called converted text file. Now, I would hand over the control to Sneha Arora and she will be explaining the other two functionalities of our project.
Thanks, Pratika. So, coming up with the pattern searching. Input of the users is matched with the strings in the text files and thereby finds a pattern. We have implemented Boyer-Moore search algorithm as its very efficient string search algorithm. This algorithm enables us to skip multiple characters of same time rather than searching every single character in text, unlike the brute force search algorithm. We basically construct a bad match table where the table never holds elements smaller than 1. The pattern is compared consecutively to the text starting from the tail, which is the rightmost character. Once a mismatch is encountered, we shift the pattern to the right corresponding to the value in the bad match table. This algorithm is comparatively faster than the brute force search algorithm. Also, the data structure which we have implemented is the hash table. It is used to store the occurrence of the search word in each file. Following is the output snippet that we have implemented. So on taking the input from the user, it goes under the search method where the Boyer-Moore algorithm is applied and it provides the occurrence of the position of the word found in the text file as it's shown here. Coming up next, we have the page ranking feature. Basically, a page ranking is a Google search algorithm that ranks the web pages. It enables us a way where we can measure or attain a rough estimate about the importance of a website page. Since the importance of a web page is measured by its popularity, that is, how many income links it has, we can view the importance of a page as the probability that a random surface on the internet that opens a browser to any page and starts following hyperlinks visits the page. As a sorting technique, we have used collections.sort, which is a Java inbuilt function which internally uses the merge sort. For working of the page ranking feature, we start with a set of pages. We crawl the web to determine the link structure, assigning each page on the initial rank of 1 by n, and successively we update the rank of each page by adding up the weight of each page that links to it, divided by the number of links coming from the referring page. As a future practice, page rank algorithm should add a damping factor at each stage to model the fact that users stop searching. Following is the output snapshot, where the page ranking algorithm is applied, which ranks the pages based on the references of the word in the text files. Following, Mayank will give you a walkthrough of the whole project's flowchart and following the code.
Thank you, Sneha. Now I'm going to explain the Atoms flowchart. So our Atoms flowchart starts with a welcome text, and then the URL which needs to be crawled is given as an input by the user. Then the web crawling happens, followed by an HTML to text conversion with the help of a JSoup library, which is an open source Java library. Afterwards, the word which needs to be searched is input by the user. And if the word is found, then the pattern matching using the Boyer-Moore algorithm happens, which eventually results in ranking the page using the page ranking algorithm, which internally uses the merge sort. Afterwards, sorted pages are provided as a results. Meanwhile, the pattern matching Boyer-Moore algorithm also helps in calculating the frequency count and occurrences of that searched word in each file. After showing all these results, the user is asked if you want to continue or not. If the user replies with a yes, then the word which needs to be searched is again input by the user. Otherwise, if he says no, then the web search engine closes and we can exit from that engine. So now I'm going to run our application and give a code walkthrough of the same in between. So this is the welcome text for our Atom web search engine, and these are the team members' names. Now I'm going to search for a URL which needs to be crawled. So it shows crawling has been started for this URL Geeks for Geeks. So meanwhile crawling happens, I'll walk you through the Java classes we have made in the application. So first one is the Bohr-Moore algorithm. So this is not a simple pattern search algorithm which is used to search for the given text in the required input text file. This is followed by crawler.java. So this crawler.java uses two main functions, crawling and HTML to text conversion. Coming first to crawling. So crawling uses a hash set which is of data type string. In this, all the HTML links are added and then the control passes to HTML to text conversion. In HTML to text conversion, all the URLs are taken as input which are in HTML format, and then which these are converted into text format, and then they are stored in a converted text files which is shown here in the left hand side panel. These are all the text files which have been saved using file writer. Now we can see crawling has been stopped for this URL and HTML pages have successfully been converted into text files, and text files are stored in at this following path. Now we will enter the word which needs to be searched. So let us enter geeks. So we can see occurrence of the word geeks at different positions in a specific file has been displayed. For example, these are the positions of geeks in file this.txt, and afterwards the ranking of these web pages has been showed, which is in the decreasing order of the frequency count of the word. These are the top 5 pages which have the word geeks in it. Now our application asks if we want to continue or no. So if I say yes and I enter a misspelled word, for example GIK, so it says given word not found, which is as per our expectations. Now if we want to end our application, we will simply enter N, and now we can see we have exited from our application. Now coming back to the code explanation, so we can see this is the search word class where word search is the method which simply finds the word at different positions in a particular file. Next one is the sorting.java, which is used in web page ranking, and it sorts all our pages in a decreasing order using collections.sort, which internally uses the merge sort algorithm. And at last, we have the web search engine, which calls all our different methods from all the above mentioned classes. Now coming back to our PPT, in conclusion, we can see our course Advanced Computing Concepts helped us learn about the theoretical and practical knowledge of data structures and algorithms via assignments, tests, and projects. Atom web search engine has been developed using the concepts taught in the class in an optimized manner. Now I'll hand it over to Sneha to tell us about the future scope of our application.
Thanks, Mayank. So, as the future scope of a web search engine implemented, so the GUI, which is the graphic user interface, is to be implemented. The results that are stored in the memory will thereby optimize the time complexity. There is an equivalent scope of crawling more complex websites. And as of now, we are aiming to search the patterns of strings, but we can even further aim to pattern matching on images in the future. Currently, we use the Boyer-Moore algorithm for the pattern searching, but we can implement the different algorithms like KMP and the TST, which is the ternary search tree, for better results and to serve as a comparison among the different algorithms. So this marks the end of our presentation, and thank you for watching.